Hi, welcome back. So in this video, I would like to discuss a bit more how to compute the correlation coefficient and what is even more important, how to choose between two options, Pearson correlation coefficient and Spearman correlation coefficient. So please consider the following problem. You collect a set of data containing information on age, income, and the highest scientific degree completed. You want to investigate whether there is a positive correlation between age and income, as well as between education and income. And here we've got the data. So when it comes to age and income, with some reasonable degree of approximation, you can indeed conclude that those variables can be classified as continuous and numeric. And when it comes to education, at least in the way this variable is presented, um, personally, I have some doubts. So that's why when you conduct any kind of statistical inference, it's a good idea to start with describing the variables, analyzing the data, and analyzing descriptive statistics. So in our case, age is indeed a numerical, a continuous variable. Income also numerical and continuous, and education is an ordinal variable. So here you can indeed establish some kind of hierarchy. So 1 stands for high school completed, 2 BA or equivalent, 3 MA, Master of Science or equivalent, and 4 stands for PhD or equivalent. So you can indeed find some hierarchy in this case. But again, you cannot make any reasonable conclusion regarding the difference in the value of this variable. So it does not imply that when it comes to the scope of knowledge and competence, the difference between high school and BA is the same as between MA and PhD. So this is exactly what we mean when we say ordinal variable. So, just by looking at the data, you can already figure out that in case of correlation between education and income, you are not able to use Pearson correlation coefficient for a very simple reason, because one of those variables, namely education, as we discussed a second ago, is not continuous and numerical. So this is just an ordinal variable. Okay, so stage 1 is over. At stage 2, it's always a good idea to compute some descriptive statistics. Again, at this point, it's not that useful because you can use it in order to assess whether the data is distributed normally or quasi-normally, because in our case, mean is quite close to median, which indicates that even if the data is skewed, the skewness is not that significant. But perhaps at this point, this will be enough for us. So the next step is visual assessment of the data. First of all, it's a good idea to check for normality. When it comes to testing for normality, I mean conducting a formal test in order to investigate whether you can or cannot reject the null hypothesis about normal distribution in Gretel, you have to collect at least 30 observations. So this is not the case in our situation because we have only 15 respondents. That's why, we simply cannot run this test. We do not have enough data. However, you know visually what normal distribution is supposed to look like. So you remember bell shape, symmetrical, and this is not the case. So even though we cannot really compute this distribution for education variable because, it's not continuous, In case of net income and age, the distribution is not normal either. So sometimes for a really small sample, it's still fine to apply Pearson correlation coefficient, again, even though the data is not distributed normally. But if you want to stay on the safe side, Spearman correlation coefficient is the better option. And finally, you can test for monotonicity and linearity. So in this case, you can use a scatter plot command in Gretel. Basically, it just puts one variable on horizontal axis and the other one on vertical axis, and then you can make some conclusions about the trend. By default, it also runs a very similar regression model, very simple regression model, where variable on horizontal axis stands for x variable and variable on vertical axis is y variable, but we are not really interested in it. However, if it is possible to draw this regression line, then there is indeed some reason to suspect that this relationship is strong and linear. So in case of education and income, the function indeed looks monotonous. So I mean, even if you look at the single observations, you can indeed see that with increase in the value of education variable, income variable increases as well. But in case of age and income, this is not true. So maybe there is some relationship, it's just nonlinear, but from my perspective, it's too messy. So you see, when you go from this point to this point, age increases, income decreases. So perhaps this relationship is non-monotonic, as we discussed before. And yeah, again, for a good reason. So typically, when you are relatively young, getting older means getting higher level of income, but after middle age, probably this trend reverses. So just to conclude, we can suspect that the function describing the relationship, okay, maybe not a function, trend, describing the relationship between income and education is monotonic, I'm sorry. But in case of age and income, it does not seem to be true. So finally, we can calculate Spearman correlation coefficient between those two pairs of variables, because first of all, data is not distributed normally, even in case of age and income. Also, there is little evidence of linearity of this trend, even limited evidence on monotonicity, I would say, but nevertheless. So yeah, Spearman correlation coefficient seems to be a safer option, just like non-parametric test is a safer option compared to parametric test. So that's why finally we compute Spearman correlation coefficients based on the ranks we have defined. So again, in case of income, there is indeed quite a strong positive relationship. Again, I cannot make any conclusion about linearity because this is not what Spearman correlation coefficient is about. And in case of age and income, so basically 0.5 is like a threshold value when you conclude there is no strong or even moderate correlation between two variables. So there is still some, but maybe because of non-monotonic relationship, maybe for some other reasons, we do not have any strong evidence in favor for positive correlation between age and income. And we can go back to our table with critical values. So for 15 observations, our result for age and income is only significant at 10% significance level, for two-tailed test and 5% significance level for one-tailed test. Okay, so thank you for watching. I hope it's clear now and see you in the next lecture.